What if everything you can see, everything you know, is only a tiny fraction of reality? What if the universe is mostly made of something completely invisible, something we still don't understand? Imagine this. We look up at the night sky and see stars, planets, and distant galaxies. It feels like we're witnessing the full picture of the universe. But in reality, what we see is only a very small part of what actually exists. According to modern science, all the visible matter in the universe, including stars, planets, gas, dust, and even ourselves, makes up only about 5% of the total universe. That means the remaining 95% is something else entirely. Something we cannot see, cannot touch, and cannot directly detect. This is where dark matter comes in. Dark matter is one of the most mysterious and fascinating concepts in modern physics. It doesn't emit light, it doesn't reflect light, and it doesn't interact with electromagnetic radiation in any way we can detect. In other words, it is completely invisible. And yet, despite being invisible, scientists are almost certain that it exists. But how can we be so sure about something we've never seen? The answer lies in its gravitational effects. When astronomers began studying galaxies in detail, they noticed something that didn't make sense. According to the laws of physics, stars that are closer to the center of a galaxy should orbit faster, while stars farther away should move more slowly. This is exactly what we observe in our own solar system. However, when scientists measured the rotation speeds of galaxies, they found something completely unexpected. Stars at the outer edges were moving just as fast as those near the center, sometimes even faster. This observation created a major problem. Based on visible matter alone, galaxies simply shouldn't have enough mass to hold themselves together at those speeds. They should have flown apart billions of years ago. But they didn't. Instead, they remained stable. This meant that there had to be some kind of unseen mass providing additional gravitational pull, something invisible, yet incredibly influential. This idea was first proposed in the 1930s by Fritz Zwicky. While studying clusters of galaxies, he realized that the visible matter wasn't enough to explain their behavior. He suggested the existence of missing mass, but at the time, his ideas were largely ignored. It wasn't until the 1970s, when astronomer Vera Rubin conducted detailed observations of galaxy rotation curves, that the evidence became impossible to ignore. Her work confirmed that galaxies were surrounded by vast halos of invisible matter. So what exactly is dark matter made of? That remains one of the biggest unanswered questions in science. One leading theory suggests that dark matter consists of unknown subatomic particles that rarely interact with normal matter. These particles could be passing through us constantly without us ever noticing. Right now, as you listen to this, billions of these particles might be moving through your body, your surroundings, even the Earth itself. Another possibility is that our understanding of gravity is incomplete. Some scientists argue that instead of adding invisible matter, we may need to modify the laws of physics themselves. In this view, what we call dark matter might actually be a sign that our current models of the universe are missing something fundamental. To solve this mystery, scientists around the world have designed highly advanced experiments. Deep underground laboratories are built to shield detectors from cosmic radiation, allowing them to search for rare interactions between dark matter particles and normal matter. Powerful particle accelerators, such as those operated by CERN, attempt to recreate the conditions of the early universe, hoping to produce and detect these elusive particles. Space telescopes scan the cosmos for indirect signals that might reveal the presence of dark matter. One of the strongest pieces of evidence for dark matter comes from a phenomenon known as gravitational lensing. According to Einstein's theory of general relativity, massive objects can bend the path of light. Astronomers have observed this effect in regions where there is not enough visible matter to account for the distortion. Once again, the conclusion is clear. Something invisible is there, shaping the structure of the universe. Today, scientists estimate that about 85% of all matter in the universe is dark matter. This means that everything we know, every star, every planet, every galaxy, is just a small fraction of what actually exists. In a very real sense, we are living in a universe dominated by something we cannot see. Even more fascinating is the role dark matter plays in the formation of cosmic structures. Without it, galaxies might never have formed in the first place. Dark matter acts like a gravitational scaffold, pulling ordinary matter together and allowing stars and galaxies to emerge over billions of years. Without it, the universe would likely be a much more empty and chaotic place. And yet, despite all the evidence, we still don't know what dark matter truly is. It remains one of the greatest mysteries in modern science. Solving it could lead to a deeper understanding of the universe, potentially reshaping everything we know about physics, space, and reality itself. So the next time you look up at the night sky, remember this. What you see is only a tiny fraction of what's really out there. The vast majority of the universe is hidden, silent, and invisible. And perhaps one day, when we finally uncover the truth, we will realize that the universe is far stranger and far darker than we ever imagined.
Thanks so much for watching my video. I really appreciate you taking the time to be here. If you enjoyed it, don't forget to leave a like and consider subscribing. It really helps the channel grow and keeps me motivated to create more content like this. Also, if you want to be notified right away whenever I upload a new video, make sure to turn on the notification bell so you don't miss anything. Thanks again for your support, and I'll see you in the next video.